waiting way too long. Yeah, I've been out here trying to get it. Yeah, I've been waiting way too long.
This is the video for 3.3, proving lines are parallel. So what we have here we have the converse of the postulate and then the theorems we talked about in the last lesson. So the corresponding angle's converse says if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. Remember, converse is if Q, then P. So that is the converse of the corresponding angle's postulate. So again, this is still a postulate that we can use in our proofs. Next is the alternate interior angle's converse. This is a theorem that we can prove. If two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So now we're saying, okay, we have congruent angles, therefore we can conclude that the lines are parallel. Whereas the original was that if the lines are parallel, then the angles are congruent. So I'm not going to read all of those to you, but again, that's the converse of those theorems that we talked about last. And then also the transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So if I have these two lines, okay, I call this line X and this line Y, and I say that X is parallel to Y, and I also say that Z is parallel to Y, then we can assume that X is parallel to Z. Okay, so it says solve for X so that P is parallel to Q. Okay, well, what kind of angles do we have here? These are corresponding angles. And so we know that if the corresponding angles are congruent, then the lines are parallel. So we want these to be congruent, so we're going to set them equal to each other. And we're going to solve for X. So 3X equals 60, X equals 20. So that X needs to be 20 in order for these two lines to be parallel. That would make the corresponding angles congruent, meaning their measures are equal. All right, now we're going to prove that that these two lines are parallel. We're given that the measure of angle 4 equals the measure of angle 5. What kind of angles are those? Those are alternate interior angles. So we are proving the converse of the alternate interior angle theorem. So we know that the alternate interior angles are congruent, and we're trying to prove that the lines are parallel. So if I know 4 is equal to 5, and I know that the measure of angle 1 is equal to the measure of angle 4, that's the vertical angle theorem. So if 4 equals 5 and 1 equals 4, then that means 1 equals 5. That is the transitive property. You have two things equal to the same thing. That's the transitive property. So if 1 equals 5, then I know by the postulate, the converse, corresponding angles converse, if the corresponding angles are congruent, then the lines are parallel. So I have now stated that these corresponding angles, 1 and 5, those are corresponding, are congruent because they're equal. Then I can say that G is parallel to H, and that is the converse of corresponding angles postulate. So notice that that postulate comes in handy when we're trying to prove this. So we have two diagrams here, and we're trying to decide if we have enough information to determine that M is parallel to N. So let's just review a couple of things here. Our transversal, okay, M and N are our two lines that are being cut by the transversal. So that's our transversal, and here is our transversal. So what is the relationship of these two angles? I'm going to call this angle 1 and this angle 2. What is the relationship of angle 1 and angle 2 in example A? Those are alternate exterior angles. They are on opposite sides of the transversal, that's alternate, and they are on the exterior of the two coplanar lines M and N. They're on the outside of those. So if alternate exterior angles are congruent, are the lines parallel? Yes. So yes, we do have enough information. Again, that's from one of our theorems that we just talked about. That's the converse. Looking at example B, Again, I'm just going to call this 1 and this 2. So they are on opposite sides of the transversal, so that would be alternate. But one of them is on the exterior, angle 1. This is exterior. And one of them is on the interior. That's angle 2. So there is no relationship that we've discussed regarding these two angles. So there is not enough information here to prove that those M and N are parallel, because they're not corresponding, they're not alternate interior, they're not alternate exterior, nor are they same side interior.